Okay, so now that we've got a few pieces in our world, let's add a player in to be able to actually do some stuff here. So we're going to go back to our art file, and if you don't have it open, we'll pop open the little arrow to the side, and we're going to grab, we're going to use this blue guy. There's a few different colors of the same character down along here, but we're going to use the blue guy here. So we'll just take the first sprite of him, and we're going to use this as our default kind of character sprite for us to be able to see the character within the world. So all we do, as I just did, you just drag it into the world here, and it creates in our hierarchy. But we don't want it to be called sprites19. That's a kind of strange name for a character, so we're just going to rename this just to be player. So obviously our player here, he hasn't got a lot going on with him just yet. So if we were to start playing our game, for example, all we get is we've got our player. He's not doing anything. He's not interacting with our world at all, obviously. We can't get any movement on him. But this is an example here of, this is the kind of control buttons of the game. So we've got a little play button to start the game running. We can pause the game at any point when it's running, and it'll take us back to our scene view, and we can kind of make some changes. And that's kind of the main things we want to use. We don't really need to be too concerned with this button at the moment at all, really. So for now, we need to kind of give our player some things to do. So much like last time we added a box collider to these objects to make them something solid, we need to add the same thing to our player so that he will interact with these things. At the moment, if he was to go into one of them, actually if we just hit play here, we should see that at the moment, if we were to move him using the scene view here, he'll just be kind of hovering over the ground, and that's not really much use to us at all. Okay, so what we need to do is go to add component, and again we're going to add a box collider 2D, but as you can see, that makes quite a large box around the player like that. So we're going to adjust his size on the x-axis, so we're going to shrink this down, and we're actually going to go to exactly 0.5 like that. And now we have a box around our player. So now he'll actually be able to interact with these grounds here. But at the moment we just have two boxes, and it doesn't really know what to do with them. They're kind of just two pieces that are used. Once, if we were to start writing some scripts and stuff, we could make them understand how to interact with each other. But rather than having to go and create a whole bunch of code and scripts ourselves, Unity has a built-in physics system that we're going to take advantage of and use in the game here. And the way we do that is go to add component again, and we'll get rid of box in the search box up here, and we're going to start typing in rigid body, and what we want is rigid body 2D. So a rigid body 2D basically controls the object in our world. And to be honest, before we're going to make some changes to it here, but if I just move him up to here, and if we start playing our game from here, we'll actually start seeing some effects happening. So the player, as you can see, he dropped down to the ground there. We can pick him up and he'll drop him and stuff like that. If we were to put him on the exact corner, he'll drop and spin off into the world, which is not something we want either. So we're going to fix up that. So what we'll do is just go to on our rigid body 2D here, we'll go down to constraints, and we're going to hit freeze rotation. So now if we hit play this time, if we go back over to here, if we drop him just on the corner like that, now he'll just stand on the edge, which is kind of something you would more normally see in a platformer game like this anyway. So that's perfect. We've got some other things here on the rigid body. Now, we're going to see an example here now of how if you make changes to something when the game is running, it won't actually make any effect on the game here. So what I'm going to do is, just an example, if I hit him up to here and let him fall, you can see how fast he falls. But if we change gravity scale here to say 5, we drag him up, he falls much faster. If we're to set it to 100, he falls way faster. So we're going to put this back down to 1 for the moment. But if we put it at say 0.5, then he will slowly, much more slowly fall to the ground. But we've made a couple of little changes to the gravity there. But if we were to stop our game by hitting our play button again, our gravity scale will go back to 1, which was the value that I had when we started playing the game. So it's important to remember that if you make any changes in the inspector when your game is running, they won't actually apply to your game, which is an important thing to remember if it's something that you change in the future. And then you have to always remember that when you stop the game, you need to make the same changes back into the world again. But that's the basis of adding some physics to our player. So now he's able to actually interact with our world a little bit. So we need to give him some movement so he can actually do some more interesting things. Okay, So now that we have our player and he's actually able to do some things, we need to give him the ability to move around. And obviously to start being able to interact and actually do things in the game, we're going to need to start writing some new code. So we're going to go back to our assets folder here. We're going to right click, go to create folder, and we're going to call this folder our scripts folder, where we're going to store all our scripts that we're going to create for controlling things. And then inside that folder, we're going to right click again. We're going to create a C# script like this, and we're going to call this player controller. Now it's important when you're naming your script not to have any spaces in between the words, because we can have spaces in the name of a script, or else it'll mess everything up completely, basically. And a kind of normal naming convention is to put a capital letter at the start of every word, just so you're able to, your eyes can easily and quickly tell apart what's the end and the start of a new word. So we've got player, and we've got a capital C for controller because we've no space, so we need an easy way to be able to remember what's which. So now that we've created that, we're going to double click on that, and it'll open up our script in Unity's kind of built-in script editor, which is called MonoDevelop. Okay, so once our MonoDevelop is open with our script here, we see we get the basic kind of default stuff that are filled in to our scripts to start off with for every script. So what we've got here are our start function and our update function, and these are kind of the two main basics of what happens in Unity. And these are basically standard things that are built into Unity that we don't need to construct ourselves, and these are based on the time of stuff in the world. So basically this little start function here, which is wrapped between these two little curly brackets, so anything we put in between these two curly brackets will happen during the start. And the start doesn't just mean the start of when our game starts, it means the start of any particular scene when it starts loading up, or if we were to bring an object into the world in the middle of a scene, that would be the start. So it basically means the start of whenever an object that has a script attached to it, whenever that script first becomes active in the world. And then we've got our update function here, and our update basically occurs every moment of the game. Every time a frame of the screen takes place, our update is called, and anything within here will take place constantly and repeatedly over and over again. So as you can see, we've got little comments above each one of these that basically says the same things, so that we always have this reminder of these basic elements. So because we know that we're going to be playing our game, and we always want to be ability to be able to move around and stuff like that, we're going to use the update loop here to be able to take an input of when we're moving left or right and be able to move the player like that. And one of the good things about Unity, if we go back into the main program here, is it's got a whole bunch of inputs already worked out for us. So if we go to edit here and go down to project settings and then input, over in our inspector here it opens the input manager. We're going to click on the axes here, and we've got a whole bunch of things set up already. So we've got horizontal, vertical, that's basically moving left and right, moving up and down, obviously. We've got fire 1, 2, 3 and jump, and all these other kind of different things for us to use. So if we were to just click on horizontal here, for example, by default that's set up to work with the left and right arrows, the A and D to move left and right, and it's also set up to use a joypad for us. So it's all stuff that we don't have to work out to set that up ourselves. It's built in by default to Unity, which is really handy and really useful for the future. So what we're going to be concerned with for the moment is this horizontal axis, and we're going to be controlling our player using that rather than using a specific button to record things. So say, rather than saying if the player presses the left arrow, move left, what we're going to say is if the horizontal axis is going to the left, then move the player to the left, because they could be using a whole bunch of different inputs to cover that one same thing that we want to do. So what we're going to do here is, because this series is built around, obviously, if you have no understanding of coding, we want to keep things nice and simple and sensible and explain everything as we go through, rather than bombard you all with a bunch of code and having to try and remember how everything works. We're going to go through things as we encounter them in the series. So obviously, if we're going to be using movement, we want to be able to control the speed that the player is moving around in the world. So we'll need a value to do that. So above our start area here, but below this public class, so we know we're inside this curly bracket. So basically we have curly brackets that say anything within this should be run at this time. So we've got this overall kind of curly bracket which controls the whole script of what we're doing. So just below that we add a couple of spaces in there, and what we're going to do is we're going to type in public float move speed, all one word and with a capital S in the middle like that, and then we're going to hit a semicolon at the end like that. So if you haven't encountered any of this stuff before, we'll go through now what all these things are. So move speed is just the name of a variable that we're creating right now that we want to be able to use within our game, and we know that we want to be able to affect the speed of the player, so we're just calling it move speed. Float here, float is a type of number. There's two main types of number within Unity. There's floats and there's ints, and basically the difference between them is an int is just a whole number, so only like 0, 1, 2, 3, 4, 5, etc. It could be minus numbers either, but floats are numbers with decimal places, so 1.3, 59.75, 100, whatever. That's basically the main difference between them. So we want to use a float because if we want to get very specific with how fast we want our player to move, we could have it be like 4.5 or something like that. Who knows what you want to do. And then finally we've got this first part here, which is public. And there's two different ways of having a variable, which is a variable is anything that we're creating that we can kind of interact with in our script. So there's two different ways of having them. We can have them public or private. The reason we want to do public is because we want to be able to make changes to this move speed ourselves. So if we're hit save here now by pressing Control and S, and sometimes you get a message you might need to convert the line endings of your scripts. Just always hit convert and you'll be absolutely fine. It's kind of a strange issue with Unity that is, depending on which system you're using, you could end up with that error, but it doesn't actually break anything for us. So we've saved the game, and if we go back into Unity here, there's a little spin circle down here in the corner, and that means that the script you just created is compiling to be able to use within the game. So we have to wait for that to go away, and then we'll go to our player here, and we're going to add that script that we just created to him. And there's a couple of ways we could do that. We could go into our scripts folder, and if we just make sure our player is selected, we could click and drag this over to the add component area here, and that would add it to the player. Or we could go to add component, delete from that box there. We could go to scripts down the bottom and add the player controller like that. Or again, we could start typing it in. We could start typing in player, and we've got our player controller, and we could select it that way. Now you might notice in here that we've got a space in between the names of things, and we made sure that we didn't put a space in the actual name of the script here, and that's because Unity by default knows that the kind of normal convention is to break apart words by there being a capital letter, so it'll automatically put a space in to make it nice and easy to read over here. So if we were to click on that now, it'll add to the script, and we'll see down here we've got move speed as a variable. So now we can add a number down here that we can move the player around, and the reason we're able to see and be able to make changes to that here is because we made it public. If we were to just change it and make it private like this and hit save and go back in, so once again we wait for it to compile down the corner, and then once it compiles we'll see that our move speed disappears, so we're not able to actually control that. So we want to be able to control it, so we'll go back in here and reset it back to be public. So the next thing we want to do is we're going to be using the physics of Unity to move our player around. As we know here that we've got something, if we hit play here, we know that a rigid body is making us fall down to the ground like that. So we know that our rigid body is basically using physics forces to move our player around, and we're going to use the same system to move our player from left to right and stuff like that. So we know that we're talking about using the rigid body here to move our player. So what we need to do is, on our script here, we need to be able to access this rigid body. So we know that our script is attached to our player, so we know that that the rigid body is on the same player. So we're going to need to be able to access that rigid body. So over here, we're going to type in, this time we're going to say private, because although we want to be able to access it, we don't need to be able to look at it down here. So we're going to say private rigid body 2D, which is the name of this component here, and you'll see we'll get a kind of autocomplete here, so we can like select that like that, and we're just going to call it my rigid body. So this is we'll know that the variable we want to look for will be the one that's attached to our script. So we're basically, what we're doing here is creating an empty space for a rigid body variable, but it won't magically know that we want the one that's attached here. We could be equally looking for a rigid body attached to some other object, attached to an enemy or something like that that's moving around the world. So we want to make sure that we're talking about this specific one here. So what we'll do is, in our start function here, between the curly brackets, we're going to type in my rigid body. So that's the variable we just created here. My rigid body is equal to get component, like that. So we know that all these little separate pieces are components, and we want to get this component in specifically. And so we'll say get component, and we'll put a sharp arrow like that, and we'll type rigid body 2D, then put another closing arrow. We put some normal brackets like that there, because this is a function. You don't really need to understand why we're doing that just yet, but just know that we just have to put them in there like that, and then a semicolon at the end of the line here. Oh yes, I didn't say a semicolon at the end of a line like we have here basically tells us and tells Unity that the end of a particular bit of code has taken place. So on this line here, for example, our public float move speed, we have to put a semicolon, because or else it'll think that our private rigid body thing here is all part of the same line, and it'll be trying to work out what's this huge big long thing that I don't understand, and it'll give us an error, and that won't work. So it's just always important to remember, at the end of a line, basically when you're telling Unity to do something, you want to put a semicolon like that. Okay, so what is our get component rigid body 2D doing here? Basically all it's saying is, okay, we know that we need a rigid body to go into this kind of empty variable that we made here, and we know that we have a rigid body attached to the same thing that our player controller is attached to. So all we're saying is, okay, find a component that we're attached to that is a rigid body 2D one, and that's the one we're going to be referencing here. So just as an example, we'll actually just change this to be public here, and we'll save it, and we'll go back into the game, and we'll let it compile, and we'll see what happens when we run the game with that bit of code. Okay, so by default we've got a space now for my rigid body, but there's nothing in it at all, because it doesn't know, like I said, it doesn't magically know which rigid body we want to use. So I mean, we could actually drag the player himself into that slot, and that would know what it is, but it's better to be able to let it find it at the very start of the game itself, and then we can go from there. So then we start the game, and it automatically fills in the space that we need. So now we know we're talking about the rigid body that's attached to the player. So if we click on that, we can see it highlights which piece is what is connected by this thing here. So that's exactly what we want to happen, and how we want to run things. So now that we know we're talking about the rigid body, we can start adding some forces to move the player around in the world. Okay, so now that we know we're accessing the rigid body attached to the player, we're going to need to start actually taking some input and moving the player around in the world. So the way we're going to do that is by using a thing called if statements. And basically, an if statement is just a way of checking if something is happening at the moment. So what we'll do in our update loop here, in between our two curly brackets again, so that we know we're running within that, we'll say if, and then we're going to have a bracket, and we'll just put a space there for now, and a close bracket. And then after that, we're going to put some curly brackets like that. And that's the this is the basic structure of an if statement. So what happens is we have our if, and it's saying, okay, if something, and the something will go between these brackets. So this will be the thing we're checking. So we're going to put in here if there's any movement going on, then within the curly brackets after that, we'll tell it to do something, which will be, in our example, we'll be telling our rigid body to start moving in one direction. So it's very straightforward, and it'll become more clear as we actually start doing stuff with it. So within the curly bracket here beside the if statement, what we want to do is be able to check if something in particular is true, so that we can run the bunch of code that we want to put in down here. So we will say, for example, in here, what we're going to want to check is if input is being pressed for us to move the player to the right. And the way we're going to use that is by using the input system that we've already discussed back here. So if we go to our project settings and to our input, we can see on our axis here, we've got all these different things. So we've got a horizontal and a vertical axis in particular that we want to use. And we want to use specifically, we want to use the horizontal axis. So when the player is moving left or right, basically. So we know we want to use the horizontal axis. So we're going to use that on our input in here. So we're going to type in, inside the brackets, we're going to say input dot get axis. And if we get this far in get axis, we've got two little options here in our autocomplete. And basically the difference between these is we have get axis and get axis raw. And get axis raw is the exact input that's being pressed at the moment between, and it goes basically between 0 and 1. 0 being nothing being pressed, and 1 being at the moment we're pressing over to the right all the way that we possibly can. So get axis raw will tell us the exact thing that's being pressed at the moment, but get axis will kind of add a little bit of a delay to our inputs like that. It's kind of more useful for 3D games, especially as our characters moving around in the world. You want to be able to go slowly and gradually moving. But in a 2D platformer like this, we want to have very precise controls. So we want to be able to move at full speed straight away. So we want to say get axis raw, like this. Oh, no, if we could spell it properly. There we go. So we want to get the exact input that's happening at the moment. So in our input.getAxis raw, then we'll put a couple of curly brackets like this. And we know we want to access the horizontal axis. So we will put, first we put a quotation mark like that. Then we'll type in horizontal and then put another quotation mark. So this creates a thing called a string, which we'll come back to in the future and discuss properly. But for now, you just need to know a string is basically a word or a sentence or anything like that. Just a string of letters or numbers. And that's why it's called a string. That makes up a name. And just so that we know the name of the thing, the name of the axis that we want to get input from is the horizontal axis. So we know we're talking about this horizontal axis, but at the moment all we're checking is if that thing exists, and that's not what we want to be checking. So we want to check if that is greater than, we'll say 0 for the moment, but we'll come back and take a look at that in a little bit. So basically what we want to say is if the input on the horizontal axis is greater than 0, we're going to do something in here. And the reason we say greater than 0 is because if we think of our horizontal axis as like moving from left to right, when it's dead in the center, it's at 0. When we're moving to the right, it goes up to 1, and we're moving to the left, it goes to -1. So what we want to say is, okay, if we're going to be moving to the right, then we know that we want our horizontal axis to be greater than 0. So that's when we know that if this is true, then we want to start doing something down here to move our player. So now that we know that we're checking for moving to the right, we can say in here, my rigid body dot velocity. So the velocity is obviously how quick the player is moving. And we know that we want to use our movement of our rigid body. So within our rigid body has a component of velocity that controls how fast it's moving within the world. So we're going to be making changes to that to make our players velocity to the right be whatever our move speed is up here. So we say my rigid body dot velocity is equal to mu vector tree. Okay, so a vector tree is basically just an object that has three values, an x, a y, and a z value. So if we just go back into here and click on our player, for example, a vector tree of our position is these three values here. A vector tree of our rotation is these three values here. A vector tree of our scale is these three values. So on our rigid body, the velocity that's being used at the moment already has an x and y and a z value. Because we're using a 2D game, we're not using the z to go back and in and out of the screen. We're kind of only really using x and y. But the way Unity works, it also factors in the z value, even though we're not actually doing anything with it. So now that we know we want to make a change to the velocity, we have to make our rigid body be equal to a new vector tree. And the reason we say new is because we're creating a new vector tree that we want this to be equal to. So we've got a new vector tree, and we're going to put an open bracket here. So we need to give this an x, a y, and a z value. And we know we want to move on the x-axis. And we know we want to move on the x-axis to the right. So what we'll do is, just in here, we're just going to set our move speed. So our move speed is whatever value we've given it here. And we know that our move speed, whatever we set it to be, we know that's how fast we want our player to move to the right. And we know he's moving to the right, so we know it has to be a positive number. So on our y-axis, which is our up and down, we don't want to make any changes to that. Say, for example, our player is falling down in the world. We want him to continue falling. We only want to make changes to whether he's moving to the left and right. And the way we can keep it so that it's not making any changes, and we know that it's using the whatever speed it's already going at, is here we'll type my rigid body. So my rigid body dot velocity dot y. And what that'll do is it'll check whatever y velocity the rigid body already has. It'll just pop it back in here again, so that it'll keep the same thing going, and it won't actually be making any changes to it. And then finally, our z value, because we know we're not actually doing anything with the z, we're never trying to move the player back into the background or closer to us, because that doesn't make any difference. We're just going to set this to be 0f. So you might be wondering why we put 0f here and why we did it back here as well. Basically, all that means is it's 0 and it's a float number. Because when we're working with our rigid body velocity and stuff like that, we always have to be using float numbers. And if we don't put the f, sometimes Unity might think that it's an int number because it doesn't have a decimal point in it. And as we discussed before, we have floats and ints are two different kinds of numbers, and ints are ones with whole numbers. So it might automatically think that we're talking about a whole number here, and it'll start trying to put a whole number or an int value into our float, and those don't always come back, aren't always compatible. It's usually fine with 0. We could honestly put 0 and it would actually just absolutely be fine. But sometimes when we start using higher numbers, it can cause errors. So it's just good to get into the habit of putting an f at the end of a number so that Unity will always know what it's doing. Okay, so now, again, as we discussed before, we want to put a semicolon at the end of every line so that Unity knows that it's actually doing something here. And the reason we don't put it here is because this is when we're checking something, and then here is when we're actually doing something. So here we don't put a semicolon because we're only checking to see if this thing is true, but here we're telling Unity to do something, so we're saying, okay, put a semicolon at the end, because you need to remember that an action has taken place here, basically. Okay, so we're going to save this and go into Unity, and we should be able to see our player actually moving in the world. So once it compiles down on the bottom here, we're going to scroll down, and we're going to set his move speed to be about 5. And now if we hit play, remember there's a whole bunch of different options, so we should be able to use the right arrow, or we should be able to use D by default. You can of course go and change all those settings whenever you want to, but we'll stick with them for now. So now we should be able to, if we hit D, we see our player moves over to the side and he kind of falls off to the bottom like that. You might have noticed if you only tap your movement to the right, the player will keep going off to the side. So obviously that's not what we're going to want, so we're going to fix that as well. But for the moment we can see our input is actually doing something. So now we need to do the same thing, but basically the opposite way around. We want to check if the input is below 0. So rather than just writing out a whole new if statement, what we actually want to do is check. We want to say else, and then space, and then if. And the reason we do this is because we're not going to end up in a situation where our player can move left and right at the same time. So what we want to do is put an else statement in here so that he can only do one or the other. So we're basically then just going to copy all the rest of this. So from the first bracket here down to the closing bracket of the squiggly line bits, we're going to copy that, and then we're going to paste it in there like that, and we're going to make a couple of changes to the little bits of script here. So input that get axis raw horizontal, instead of checking if it's greater than 0, we're going to check if it's less than 0. And on the velocity, instead of making the move speed be a positive value, we want it to be a negative value because we're moving to the left, so we want the velocity to be less than 0, because 0 velocity would be staying still. A positive velocity is moving to the right on the x-axis, and then a negative velocity will be moving to the left. So to do that, all we have to do is simply add a minus in front of move speed, so then it becomes a negative number. So we know that our move speed here is set to be 5, so now here it'll just be minus 5, like that. So now we should have, if we save this and go back in and check, because whenever you add a new bit of code, you really want to always check every time and make sure that it's doing the desired thing that you want it to do. So now we'll hit play here, and we should be able to move left and right. We still get the kind of sliding around effect, but we're able to move our player left and right. So how do we stop him sliding around after we press the button? Well, basically we know that we're getting input, so if our input is greater than 0, we're moving to the right. If it's less than 0, we're moving to the left. So then logically, if our input is staying at 0, we should be standing still. So we're going to type else again here, and instead of having to write a whole nother if statement for all of these things and just to check if our input is 0, we know that either the input is above 0 and we're doing something here, or the input is below 0 and we're doing something here. And if neither of those things are true, then by default 0 must be what we're at. So rather than having to add a whole if statement, we can just add a curly bracket straight down here like this. So we don't need to check if something is true. Instead, we can just tell it to do something by default here if the other two things aren't true, is basically what we're saying. So in here, we're going to take our rigid body velocity, we'll just copy this whole line again, paste it in there, and basically instead of applying a move speed, we will set this to be 0 again. So now we're saying, okay, if there's no input being applied, then our velocity should be 0 and we shouldn't be sliding around throughout the world. So we'll hit save on that, go back in here, and once this compiles down in the corner, we should actually set my rigid body back to being private in our script as well, because we don't need to be able to see it here. It doesn't make a difference to the game at all, but we don't need to be able to see this in our editor itself. But now we should see, we can move side to side in our world just like that, which is perfect. So next thing we're going to need to be able to do is to jump to get across onto this other little platform here, because at the moment all we'll do is fall down to our doom.